Okay, so good morning, afternoon,
Доброе утро, добрый день.
whatever time zone you are at the moment in. So my name is Jiri Cincura. If you want to find me on Twitter, you can find me at cincura_net. And also, if you prefer tabs over spaces, you can go to my website www.tabsoverspaces.com. And today's talk, I will be sharing with you ways to improve your code base using Roslyn and analyzing basically your code and trying to improve it by avoiding some mistakes or some most common catches. So let's first start with how it was before the Roslyn actually existed. So before the C# compiler was actually a black box compiler. That means that you basically put source code into it from one side, and from the other side, the executable was spit out, and there was no way you could plug in into it anyway or any side. Also, there was a small difference between the compiler that was actually compiling your source code and something that's called Visual Studio Language Services. The Visual Studio Language Services is something that's powering the experience in the Visual Studio. That means for example, the green and red squigglies and IntelliSense and code completion and all this stuff. And there was small differences between what the compiler was actually able to do and what the Visual Studio Language Services was able to do. Probably the biggest drawback of this split was that when something new was implemented in the compiler, new language feature, the same feature needed to be in the Visual Studio in a separate way. It was not the one code base, one way. Also, the compiler before was written in unmanaged code, which was kind of funny because the C# team was actually writing the compiler in unmanaged code in C and C++, and not using the C# on a daily basis. So you're actually doing writing and designing the compiler and the language itself, but on a daily basis you are using some other language. So you are not kind of using it every day the way other developers are using it. Also, all the features from Visual Studio you probably know, like the refactorings, renames, and find all references. These were powered by separate pipeline through the Visual Studio Language Services, not through the compiler. So if there was something wrong in the compiler or in the language services, it was slightly different on both sides. So the Roslyn itself at the moment is actually like the next or maybe the last generation of the C# compiler. And other compilers as well, especially the Visual Basic.NET. I'm saying that's the next one. It's actually almost 10 years old now. It's an open platform. It's an open source project. It was one of the few open source projects initially available together with like MVC. MVC was a little bit sooner, but the Roslyn was close to follow. So it's not really new. It's a mature platform, and it's not really brand new. As I said, it's 10 years old. The biggest difference is that it's written in C# and other languages. For example, the VB.NET compiler is actually written in the VB, but the C# is written in C#, and the common platform for both compilers is actually in the C#. It's very open. You have access to like syntax and semantic models and so on. And it has quite a rich API that you can use for your own benefit, and we will be focusing on this in a minute. Some interesting features about the Roslyn codebase is that it's almost completely immutable. Like 99.9% of the codebase is using immutable data structures, mostly because it is easier to parallelize the code when you have immutable data structures. There's a lot of lazy initialization and lazy computation, which speeds up the compilation process, because if you are not hitting some code path or using some parts of the compiler, it does not have to initialize. And finally, it's log-free. That's also thanks to being immutable or using immutable data structures. And we will see the immutability in the code I will show in a few moments. So here is the picture of different layers of the compiler, and you can actually use all of these layers from the compiler, because the Roslyn is actually not a black box compiler as the previous one, but we can call it a white box compiler, which means it's actually open on all different levels. On the bottom part is the compiler pipeline. The compiler pipeline is basically the minimum that the compiler needs to support. There is a parser, there is a symbols and metadata import stuff, there is a binder, and finally there is the IL emitter that actually emits the IL, which is almost the final product of your .NET executable. The JIT actually needs to then translate it into the machine code. And this is really the minimum stuff to make the compiler work. On top of that is a compiler API. This is something that you would probably use because the bottom part is really like to make the compiler work. The compiler API contains stuff like the syntax tree API, so you can check the syntax of the code you are parsing, the API around symbols, and also binding and flow analysis API, so you can actually see like, is this class being used there, and what's the name of this class that's used in this method, and something like that. On top of that is a bunch of helper stuff that you can actually use to make your life easier and to analyze the code. So there are stuff like colorizer and formatter, so you can actually see it's a method, it's a class, it's an argument, it's a parameter or something like that. Stuff like navigate to, so you can actually say, hey, where is this method being used? Stuff around renaming, finding references, extracting methods, basically all the stuff you are interacting with in the Visual Studio in the first place is this layer on top of the APIs. All of these levels are open for you, so you can use them any way you want. Obviously, you want to start on the top layer because it's the easiest one and there's a lot of stuff done for you, but you can actually go a little bit lower and, for example, extract the syntax tree and manipulate with the syntax tree yourself, or check what's done on the syntax tree level. So if you check what all different APIs actually mean for us, is like the syntax tree, that's basically lexical and syntax information. That's the semicolons, that's the brackets, and new lines and all this stuff. Basically, what the compiler is complaining if you forget the semicolon and something like that. That's the syntax. Then we have the symbol API. That's basically powering like the find all references and what's this method, what's this name, is it a method, is it a class? On top of that, or maybe a little bit on the side, we have the binding and analysis API, which is basically like casting. If you are passing, let's say, integer into the method that's actually accepting a long, then obviously there is implicit cast. So the binding needs to select which method I'm going to use and select the one that's accepting, for example, the long, because that one is actually like good one to be called. Then we have the name conflicts and all this stuff. And finally, the emit API, that's finally emitting the IL to the final executable that is then saved to the disk and eventually executed. So without any more slides, let's go to our first analyzer. In fact, I will first open another instance of Visual Studio so you can see what I'm actually using, and I will create a new project. And in new project, I will search for a template. It's loading a long time, and there is an analyzer with the code fix. And if I select next one and let's call it analyzer 1 or something else, maybe there is already this name. not really. Something is not quite right. The path is correct. Not sure what's happening. Let me try again. So let's start a new project. Wait for the templates. Okay, let's try again. Nope, does not work. Never mind. When this would actually finish, it would open the same structure as I have here on the right side. So I have the analyzer itself. This is this project, and I have a test project if I want to unit test my project, which you obviously want. And then I have a project that's actually using the V6 to build the analyzer for me and debug it and eventually distribute it. The way you can distribute your analyzers is one, the NuGet. So you build the NuGet package and you put it onto the NuGet and somebody references it and uses it. That's probably the easiest one and the most common one to do it. The other one is that you actually build the Visual Studio extension, the V6 package, and you will just install it into the Visual Studio as any other extensions. There are two differences between these two. The extension in the Visual Studio is installed in your Visual Studio and works in every project you open without touching the project itself. On the other hand, if you reference your NuGet package, that means that it's in the project, so whoever opens the project is using these analyzers, and you don't have to have anything installed inside the Visual Studio itself. So let's first look into the simplest analyzer, or not the simplest, but some simple analyzer that you can actually create. I will try running it so we can actually see what is it doing. So before looking into the code, we can check what it's doing. It opens another instance of Visual Studio. This one is called experimental instance of Visual Studio. It's basically Visual Studio without any customizations you have. I can open some project, and if I open it here, usually the debugging is a little bit painful because you are actually like starting Visual Studio with your project and debugging it inside a different Visual Studio. So it takes a little bit of time to load it, and maybe a little bit more even now as I am streaming this through the browser. Okay. And if I do something like this, you can see, I don't know why it's using the global, but whatever, it's saying me that there's something wrong with my line here. I can even do through, so it's not grayed out. It has a green squiggly, and it says, if is just a statement, use a block instead. And that's if analyzer that I have in the other Visual Studio opened. So this is the experience I'm getting. So I can get red squigglies, green squigglies, different one, depending whether it's a warning, whether it's a message, whether it's an error, and other stuff. And I can actually go to this one and open the code fix. So there is a bunch of options to fix my stuff. There is a fix my if, and it's basically adding the brackets around it. So it's not a statement, it's a block. Without any work from my side, I actually even get this diff view where I can see with the green lines what was added, with the red lines what was removed, and I can even apply my code fix to the document, project, or the whole solution. So I will close this one. Yeah, I can even save it. And let's see how it's actually done. So in the initialize method, I will actually register myself to whatever I'm interested in. In my case, I'm interested in something that's based on the syntax tree. So I select the syntax kind, and I'm interested in all if statements. So I select syntax kind if statement. And the method that will be called whenever the user types some if statement in the code is this method analyze if. The method gets some context about what's happening around it. And because I know I will have the if node, the if statement around me, I can take the node from the context and cast it into the if statement syntax. So as I cast it into the if statement, I know that there will be a statement itself, and I check whether the statement is actually a block. If it's not a block, which means if it's not in the brackets, like for example here, then I do something about it. Let's skip for a moment these two lines to make it simple. So if it's not a block, I will just create something that's called diagnostic. That's basically like error, warning, and all the red, green, blue, yellow, whatever is the color, squigglies in the Visual Studio, and I report these diagnostics. The diagnostic itself is based on a bunch of settings. So there is a rule. The rule is a diagnostic descriptor. Basically, it says, hey, what's the ID? What's the title? What's the message? What's the category? Is it a warning? Is it an error? Is it a message? I'm saying it's a warning. Is enabled by default. So in case you would install this analyzer into your project, it will be enabled by default because you can enable, disable these on one-by-one basis. And there is a small description passed as well, so the user knows what's happening, and that it could be a little bit longer. All these strings, or in my case, it's a localizable string, are here on top, but you don't have to use the localizable string. In fact, you can use the normal string because who is going to localize your messages? And I don't know, probably most of the time you want English error messages and all this stuff. So, or it can be any other language, but you select just the one that you are familiar with and you are targeting or something. So normal string is fine as well. And I report the diagnostics. That's it. It will get the green squiggly. It's a warning, and the user knows, hey, there is something wrong. The if statement is not correct. And this is quite common that you want your team to use some kind of formatting rules or something like that. So for example, if the if is not in these brackets, it's wrong, and you want your team to adhere to one code style. But you might say, hey, Jiri, that's something you can do with editor config, and it will be way easier, way faster. It's just a bunch of lines in the editor config file. Why would I do it this way? Well, the biggest difference is that I can actually tune this diagnostic, this warning, to my own need. And this is where these two lines come into play. So for example, I might say, okay, the if statement needs to be blocked, needs to be in the brackets. But I have one exception. If the statement inside the if is actually a throw statement, so if I have something like if, I don't know, false, throw new invalid cast exception or something like that, then it's okay. Because this is quite common that you have some if statement that's checking arguments or something, and if it's wrong, you just throw an exception and it's okay. And this would be a little bit more difficult to do with the editor config file, because now you need to know what's actually inside the if. So that's what I'm actually doing here. I'm saying, hey, is the statement a throw statement? And if so, I'm just skipping and I'm just jumping out of the method. So if I run it again and open again the experimental instance of the Visual Studio, you will see that there will be a green squigglies with my console write line, as we saw it before. So console app. Hopefully now it's going to load a little bit faster. So now give it a one outcome, so the compiler and analyze, and there we go. We have the green squigglies, and it says, hey, there is something wrong with my if statement. And I can fix it by adding the brackets. So if I put it there, suddenly it's okay, and the green squiggly is away. So far, so good. So it works. But if I put it back, the green squigglies are there, but I would like to have a throw statement there. So I can do like throw new invalid cast exception, for example. And if I comment this one out, the throw statement is not using the green squiggly because it's a throw, and it's fine for my kind of like code style or for my analyzer itself. So this is the power you have in the analyzer. You can do whatever you want and analyze the code and tweak it the way you want. It's not only about the formatting. My second example will show a different one, but this is just the syntax type of thing. You can also see that there is one analyzer that's there from my previous attempt that says the program contains lowercase letters. So it wants me to have all the uppercases in the type. So that's another example of what you can do, like check the naming, check that the interface is starting with uppercase I, and so on. Some of these can be done with the editor config because it's about the syntax, but the next one I will show you is a little bit different, and that would be impossible to do with editor config. So I will close it, and I will quickly check the other file I have here, and that's the code fix provider. Your analyzer can actually contain optionally something that's called code fix. And when you find some violation, some issue with the code, you can also provide a code fix that's actually going to fix the code to the desired state. So in my case, it's going to add the brackets as we saw with the difference and the green lines that were showing what's actually going to change. So in this one, I have actually a method called register code fix that's saying, hey, if there is something I can do about it, I will register myself. And it says the method I am going to call is fix my if. And this is the first experience we will get with the immutability of the syntax tree in the Roslin, because I cannot actually change the syntax tree. I need to create a new one and return the new one. This is an important part because that means that as you are typing in a Visual Studio and you have, I don't know, like 50 analyzers running, the analyzers are not locking any data structures. It's not locking you from typing, and it can be parallelized, and it can be done on background in background without any worry what's going to happen with the source tree and who is going to use it, who is going to modify it. So the fix my if is pretty simple. I will get the syntax root, which is like the root of the syntax tree, and then I will call replace node. And I will replace the statement syntax, the statement node, with a new one that I create using the syntax factory. And I will call a block, and the block itself wants a statement inside. So I will put the old statement inside the new block and put it back. The syntax factory is quite an interesting class because it contains everything or almost everything you can create with C#, and the list here is really, really, really long. You can see it here with the scroll bar. It's really, really small, and you can basically find everything that's possible in the C# in this list, and it's a long, long list. So I created a block, and then I say, hey, document with new syntax root, and I basically created a new one, and I'm returning it back. You can return a document if you fixed the document, or you can return the completely new solution. So another one would be a solution, and that one means that you change something in multiple documents across the solution. So this was a little bit of the introduction of how the analyzers work. So now let's jump into something more interesting. And it's one analyzer that's analyzing the link statements. And what you probably know is that if you have a link statement, and I will type it here, let's say you have some array that's something like this, and you want to filter the odd or even numbers, you can call array.where, and let's do this one. I probably need brackets here, so it's correct. And I can call toArray again, for example. And if I call it this way, then basically nothing happens, because the where actually returns a new enumerable and the doArray returns a new array. So to keep processing my array, I need to assign it back to the original array. Just calling the methods will actually do something. It will eat some CPU cycles, but you will not be able to see the result. You need to assign it back. And I don't know about you, couple times a year I forget about it. Usually I'm adding something, modifying the code, and I forget about it. And as I'm shuffling the lines up and down and so on, I forget assigning it. And suddenly I'm looking at the code and say, hey, why I do see these numbers in the array? It should be filtered. It's not working. What's wrong? And the reason is that I forgot this piece of assignment. So this is what my analyzer is actually analyzing. So I say, hey, if you find any invocation, which really is what it is, the where and select and group by and all this stuff, I'll then call my method analyze link. In this one, I know my node will be invocation expression, and I check what's the parent of this statement. So it's an equals clause or it's an assignment. So there's an equal sign, or it's an assignment into a variable. And if it's this, then it's okay, because the assignment is there, and I can just jump out of it, return, and it's fine. If not, I will get the semantic model. This is interesting, because now I'm not working on the syntax level on the syntax tree of this, but I'm also putting into it a semantic information. And the semantic information is there to give me information whether the invocation is actually something on IEnumerable, some link statement or something like that. I'm intentionally keeping it simpler here. If it would be like full featured analyzer, it would probably need to test a little bit more. But we will go with it. So I will get the type information of my expression, and I will check, hey, is it an IEnumerable? And is it IEnumerable with one type argument? Because IEnumerable, as you probably know, is usually IEnumerable of int or something. So that's what I'm checking. Obviously, I should check like the namespace, maybe the assembly, in case somebody creates interface that's called IEnumerable. That would be pretty stupid, but somebody might be able to create it. But as I said, I'm keeping it intentionally simple. So I'm just checking, hey, is the name of the type IEnumerable, and is it a generic one with one type argument? If so, then I'm good to go. Then I report the diagnostics, and we are good to go. So let's see it in action. I will again start the debugging. It starts the Visual Studio, and we will try writing some statements. So I will again open the console app. That's kind of my scratchpad for this one. Come on. All right, let's remove this code and rhyme. So I create some array, and let's call it data and do it simple. So I do enumerable, and 1 to 128, and let's call the same story as I did before, x2 equals 0, and it says, hey, the link expression does not modify the input. That's actually what I was putting there. Rather returns new stream, yada yada. That's basically my message that I have in my code. So if I go here, and if I check what's the description, oh, sorry, it's in the resources, because I wanted to put it into the resources. It says link expression does not modify the input, yada yada. That's the full-blown message, and I even put it into IEnumerable this 0, which means there will be one argument, and I can actually pass what's the type of the enumerable. In my case, it's int 32 here in the message. So if I would, for example, create a string, so let's do or double, so it still works. Then the next statement, then it will say, hey, there is the double stuff that's happening. So let's keep it simple with the integer. This one has green squiggly, so there's something wrong. Obviously, I forgot to assign it. If I assign it, the green squiggly goes away. So with this one, you can analyze whatever you want in your code. You have all the semantic information. You can do renames. You can do fixes. You can even generate a new code if the old one is incorrect. And given that you have all the syntax information, all the semantic information, you basically have everything you need for your code. But you might be wondering, how the hell I'm gonna find that I am looking for equals value clause syntax and assignment expression syntax? That's actually a good question. Well, one option is to basically have a breakpoint here, start the debugging in the Visual Studio, type something and see what you have around. But it's kind of a long process. The easier one is if you open your other windows in the Visual Studio, and there is a special window that's called Syntax Visualizer. I will move it a little bit here on the right side, make it a little bit bigger. And if I step on something, it actually gives me the complete ambient information about this one. So I will make it a little bit bigger for you. So I'm standing actually here around the equal sign, okay? So I will use the cursor there and it says, hey, you are actually on a trailing white space. That makes sense because there is a trailing white space. It's an equals token. That's the equal sign. It's part of the equals value clause. This one is part of the variable declarator, and there is a identifier token because the variable is an identifier. Part of this is a variable declaration. It's a local statement. It's a block. And if I go higher and higher, I see, hey, it's a method declaration. And if I go even higher, I will see it's a class declaration and the namespace declaration and so on and so on. So this is one way to actually find what you are looking for. Sometimes it's a little bit tricky to find because different ways to assign value to a variable or call a method might be a different. So you might say, hey, it's actually a method call, and it's like one way to do it, but you will find that actually the Roslyn compiler has a different ways to express the same stuff. So for example, in my case, it was the equals value clause syntax and also assignment expression syntax, because I can have an assignment or equals value clause depending on how the code is actually structured. The other way to do this stuff is even from the browser. Let me bring a browser window here, and you maybe know the sharplab.io. So you can switch in the sharplab here on the right side into the syntax tree option, and it basically gives me the same stuff. It's a compilation unit. There is a class declaration, and inside the class declaration I have a method declaration, and the method has a body, and the body is basically empty. There's just an open and close brace token, and there is nothing in it. So this is even in the browser, it's easier to do it. Finally, especially if you are writing the code fixes where you need to generate a new code, there is a website. It's called roslinquarter.azurewebsites.net, and basically you paste any code you want onto the top level. So let's say I will take this method and I will paste it here, and then I click generate, and it generates me the complete syntax tree using this builder methods for what I need. So what I have is a initialize method. I have context, register node, register syntax node action, and the rest of the stuff. So it says, hey, there's a compilation unit, there is a member, and the member is called initialize, and it's returning a void statement, or void type, and there's a bunch of modifiers, and there's a list of these tokens, then it's public and override, and there's a parameter list, and the parameter list contains one that's called context, and the type is analysis context, and so on and so on. You get the idea. It's not super difficult to write this code manually, but it's really, really tedious. You can see that this code I can write in, I don't know, like 20 seconds. Writing this type of code, it would probably take me 5 to 10 minutes, even if I would immediately know what it is. So it's like a simple member access, and it's a method call, and so on. So this one is really useful if you're writing the code fix, that you can actually type your method, generate this code, and then just tweak it. So for example, instead of hard coding this method, you will actually have some variable or something that you will put into it. So that's really, really helpful website. So I will quickly jump into the slides. And there is one thing that's more in the Roslyn. The Roslyn itself is not only the compiler. It's not only something that compiles the code and spits out the stuff on the other side, but it's actually a part of all the Visual Studio solution project type management stuff. So usually you see, hey, Roslyn is a compiler, but it's actually a little bit more, because it's handling also the project files, solution files, and all this stuff. So what you can actually use is something that's called Workspaces. All the analyzers I've showed you today are running into the Visual Studio, but you can use the same code and put it into the console app and run them as part of your build pipeline, or just like a toolbox that you're running once a day, once a month or something, to check that the code is okay. It does not have to be in the Visual Studio. But what's more interesting is that you can actually analyze the whole projects or whole solutions. So I have another demo here, and this one is a normal console app. If I open the project file, it's a normal .exe file, normal console app. And I will just take a source code of the Firebird client, which is an ADO.NET driver for Firebird that I'm actually writing. It's open source, so you can get the sources yourself. And what I'm gonna do is analyze that all the types in the files have the same name as the file name. That's something you probably want to have. So if the file is called, I don't know, like foobar, then the class or the structure inside it should also be called foobar. And it's pretty easy to rename something and forget about the file, and then it's a little bit confusing that the file has a different name or something. So this would be something useful to actually run on a daily or weekly basis to check, hey, something is wrong. It's not going to cause you any problem, because the compiler does not care about the file names. But you can say, hey guys, fix this, because I have a bunch of issues here. And it's a normal console app, so I can run it outside. Does not have to be inside the Visual Studio. So what I'm gonna do is tell it, hey, this is the place where you find the MS build, because it needs MS build to actually be able to build the project, the solution, and all this stuff. I will create an MS build workspace, because I have actually a solution file, but you can also create ad hoc workspace where you are actually putting random files into it, and it's going to analyze it, it's going to work on them. Then I will call open the solution. So it opens the solution, and I will check all the projects. So the solution.projects contains all the projects in my solution. Then in all of these projects, I will check all the documents, all the files I have there. And I will call my method that's called analyze document. And this one basically says, hey, if it ends up with the C#, then I'm good to go, and I will analyze it. If not, I will just jump out of it. I will get the file name without the extension. So if it's like a program.cs, I will get the program. I will get the syntax tree. So I will get the syntax of the file. I will get the root. I will get all the nodes that are in the file, basically. And I will check, hey, is it a class declaration or is it a structure declaration? And if so, if the identifier, the name of the class or the name of the structure does not match the file name, I will just return false. This is what I'm returning here, the false. And I will also give the text, the name of the class or the structure. So I can actually report it back. And that's what actually I'm doing. I will say, hey, if it's false, if it's not okay, then console write line, the name of the document, the name of the file, and the name of the class that I have found. So this one, I can just start it. You will see it starts the normal console app. And it opens the solution, loads it, yada yada, and in a few minutes, in a few seconds, we should see that there is a bunch of files that do not actually match the names. So let me zoom it a little bit. So for example, one thing that's something that could be fixed is this null logging provider. So there is a file called nullloggingprovider.cs, but I'm actually having a class inside that's called null logger. So that was probably some rename or something, and I forgot to change the file. The same as here. There's a console logger provider class, and it's in the console logging provider file. So something that probably could be improved, could be fixed, and so on. Obviously, you can skip like nested files, nested classes, and so on. But this is really an example of what you can do. So with that, I'm at the end of my presentation. I will give you a quick summary of what we saw. We saw something that's called analyzers, Visual Studio or Roslin analyzers. These analyzers are NuGet packages, primarily NuGet packages that you can download from NuGet, put it into the projects, and they are giving warnings, errors, or messages about some violations in your code. You can enable or disable these one by one. So if you download a huge NuGet package that contains like 20 analyzers, and the one that's bothering you and constantly showing you warnings does not apply to you, you can disable it. And you can also provide a code fix that's actually going to fix the code for you, so you don't have to manually change it. And all these changes can be done on this one instance, in the whole document, in the whole project, or in the one solution. And you don't have to do anything extra for it. It just works. But it's not it. You can also take these analyzers and these code fixes outside of Visual Studio, create a simple console app, and use the Roslyn API to analyze the files and spit something out onto the console window or into the file and run it as part of your build pipeline, or just run it manually once in a while to see what's wrong in the code and whether something could be fixed. So with that, we have a few moments for questions, and if I'm not mistaken, we can do some questions live during the presentation, and then after the presentation, I will move also into the questions and answers room, and we can continue there. So if you have any questions, I suppose somebody will read it for me.
Thanks, Jiri. Thanks for your presentation. It was really engaging and interesting. And while we wait for the questions on our site, in the webcast, below the webcast, or on the 8800 number that you see, I will ask a couple of questions that I had during your presentation. In the last example, you've shown how we can call the analyzer for C# code using the console app. You launched the analyzer for the whole solution, and the question is, can I do the same without the solution file, without the project file, just for all the CS files?
I don't know whether it was a question for me or not, because I hear both the English and the Russian language together. So I've mentioned, I've catch like question or something, but there was a lot of Russian stuff around it. So I suppose we will need to move into the normal questions and answers, because for some reason I have the Russian and English together.
Okay, so let's try again. Iri, do you now hear only the English channel?
Oh yeah, now I have in English only. Awesome.
Great. So my question was that you showed an example where you launch a Roslin Analyzer using the console app for the whole solution file. The question is, can I launch Roslin Analyzer from the console app, but for specific CS files without the solution file?
Yes, you can. You need to create the ad hoc workspace. That's basically like a project file or a solution that's ad hoc, does not exist as a CS profile or anything like that. And then you will just add these files into the projects, into the documents, and then you can analyze them. Obviously, you might not have all the extra information about the types and all this stuff, because you might have edit files that are using different classes and the classes are not in the project. But as long as you keep your project like compilable, you will get not only the syntax information, because the syntax information you will get always, but you will also get the semantic information about your model. But if you're fine with just the syntax, like, I don't know, white spaces, brackets, semicolons, and so on, then you don't need to have anything extra. Just shove a bunch of files into it and you are good to go.
Great. You have also mentioned that this external console app can be used not to just run analyzers, but also to run quick fixes. Do I get it right? Is it done in some special way, or should I do something extra?
Yes, you can actually run also the code fixes. Probably the easiest way to do it is if you create a new solution with the analyzer. It creates also a test project for you. I've had it in my examples as well. And inside this test project, there's actually code that's checking that your code fix is doing what it should do. So you can take this piece of code and apply it to your file and execute the code fix itself. So yeah, it's definitely possible to do it in the console app as well, and check the test project with the unit tests. And there's a few lines of code that are actually doing it and executing the code fix on the selected piece of text.
Great. Our viewers are sending me comments that the Roslin Analyzer and Roslin code can be launched from T4 templates. Do you know something about it? Can you comment on this?
Oh, I don't know exactly what they mean. Probably yes. I'm guessing that you want to have a T4 template that's actually generating the code using the Roslin or something like that. That is probably possible. I would say the easiest one would be to create just a normal DLL file and reference this DLL inside the T4 template, but I would probably need more information why to do it, because the T4 is templating by itself. It's just not like strongly typed, and the Roslin is no templating, but it's strongly typed. So you are probably trying to match these two together, but that's kind of weird. So feel free to send me an email or something later, or we can talk later in the Q&A. And if you have more information, I will be happy to answer.